In this video, we're going to be talking about rational numbers, and our essential questions are, what are rational numbers? Can I convert repeating decimals to their fraction equivalent? Can I determine if a number is rational or irrational? And can I compare rational numbers? So first of all, what are rational numbers? A rational number is any number that can be written as a fraction. Now, we talked about fractions and decimals in the first lesson, and we spent an entire unit talking about integers. So all of the numbers that we've talked about so far in this course are rational numbers. So here in this table, we go through exactly what types of numbers can be written as fractions. So everything in this box is considered a rational number. So all of the integers that we talked about, those were positive and negative whole numbers and zero. Those are all rational numbers. Any fraction or mixed number is a rational number. Any decimal that terminates or ends, we talked about that in the last lesson, is a rational number. And any repeating decimal is a rational number. We talked about repeating decimals in the last lesson as well. So all of those numbers are rational numbers. So get a visual here of the types of numbers we've been talking about. Again, starting with the most basic counting numbers here, those are called the natural numbers. If we include zero, now we have the whole numbers. Then we include the whole numbers in their opposites. We have integers. And now we include all of these fractions and decimals that terminate or repeat or mixed numbers. And now we have the whole set of rational numbers. So these are the numbers that we're going to be talking about today. So how do you write different types of numbers as fractions? Well, in the last video, we learned how to write decimals as fractions, and that was read it, write it, reduce it. So how do you write these types of numbers as fractions? How do you write a mixed number as a fraction, because it's a whole number and a fraction part? Well, if we can think of this 6 1/6 as a fraction, 6 whole would be 36 sixths, plus one more sixth is 37 sixths. So this is 6 1/6 written as a fraction. That tells me that it's a rational number. It can be written as a fraction, 37 sixths. We call that an improper fraction, but it's 6 1/6 written as a fraction. So here is an integer, -23. How do you write -23 as a fraction? Well, you may know we can just put any whole number or integer with a denominator of 1 that can be written as a fraction. So that shows us that -23 is a rational number. It can be written as a fraction. And then here again, we have another mixed number. So 4 whole would be how many thirds? 4 whole is 12 thirds plus the 2/3 part in the fractional is 14 thirds as a fraction. So 4 2/3 is 14 thirds written as a fraction. So all of these numbers can be written as fractions. So that tells me that they are rational numbers. If we have the ability to write something as a fraction, it is a rational number, because rational comes from the word ratio or fraction. So just a side note here on the calculators that we're going to be using, if we're going to be using these to type in fractions and mixed numbers and all of these types of rational numbers, how do you do that? Well, there's an ABC button located right there on the calculator. That is your fraction button, and we're going to use that to type in fractions. So what you need to do is type the numerator first, then you press that button, and then press the denominator. So if I wanted to type, for example, the fraction 3/4 on the calculator, it'll look like this. I would type 3, then I would press this ABC button, and it's going to show up like a little backwards L on the calculator screen, and then 4. That's what 3/4 looks like on our calculators. If I wanted to make a mixed number, 1 3/4, I would type a 1, I would press the ABC button, a 3, then I would press the ABC button again, and then a 4. That's what 1 3/4 would look like on the calculator. And then if you ever get an answer, or you're adding rational numbers together later on or subtracting rational numbers, and something like this pops up, I believe that's what it looks like on the calculator. That little space right there tells you you've got a mixed number as an answer. So that's 1 3/4 on the calculator. So just a quick overview of what rational numbers will look like on the calculators that we use in class. So what if I have a repeating decimal? we said that a repeating decimal is also a rational number, so it should be able to be written as a fraction. How do you write a repeating decimal as a fraction? Because you cannot read it, write it, reduce it. That doesn't work. So if I have 0.6 repeating, I can't read that number because there's no place value where it ever ends. The place values just keep going on filled with sixes. So I can't read it, I can't write it, I can't reduce it. So how do you convert a repeating decimal to a fraction? Well, there's a little trick, and we're going to use nines in the denominator to do that. Nines will always produce a repeating decimal, so we can write repeating decimal with a denominator with nines in it. So here's how you do it. The first thing you do is the digits that repeat go in the numerator. So anything that is repeating, that's what you put in the numerator. The number of digits that repeat determine how many nines go in the denominator. So if one digit repeats, then 1 9 will go in the denominator. If 2 digits repeat, then 2 9s will go in the denominator. If 3 digits repeat, 3 9s will go in the denominator, so on and so forth. And then lastly, we just simplify the fractions. So I've got a few examples here of repeating decimals, and we're going to write these as fractions in simplest form. 0.6 repeating. So the digit that repeats is a 6. That's going to go in the numerator. And only one digit repeats, so I'm going to put 1 9 in the denominator. 6 ninths. Now this fraction reduces to 2/3. So 0.6 repeating is 2/3 as a fraction in simplest form. And if you do 2 divided by 3 and you convert this fraction back to a decimal, you will get 0.6 repeating. So that's how you turn a repeating decimal into a fraction. Looking at the next one, 0.42 repeating. Here we have 42 that repeats, 42, 42, 42. So the 42 repeats, that's 2 digits, 2 numbers repeat. So I'm going to put 2 9s in the denominator. 42 99ths, 42 99ths. And this will simplify. These are both divisible by 3. And you get 14/33 as a fraction in simplest form. So 42 repeating, 0.42 repeating is 14/33 as a fraction in simplest form. So we can see that we can write these numbers as fractions, and that's what makes them rational. We can write them as a fraction. So looking at this next one, we have -3.85 repeating. Well, I know this is going to be a mixed number. -3 and what? Well, the 8, 5 are the 2 numbers that repeat. That goes in the numerator. And 2 numbers repeat, so I'm going to put 2 9s in the denominator. And that is actually in simplest form. 85/99 does not repeat, so I'm going to leave it like that. And then we saw that we can turn a mixed number into a fraction, but I'm not going to do that here. But we can just show that we can convert this to a mixed number that is a rational number. So you might be thinking, well, if I can turn terminating decimals into fractions, I can turn repeating decimals into fractions, I can turn mixed numbers into fractions, I can turn whole numbers into fractions. Can't I turn everything into a fraction? Isn't everything a rational number? Actually, no. So what types of numbers cannot be written as fractions? Decimal values that do not repeat or terminate cannot be written as fractions, and they are called irrational. That means not rational. So here are some examples of numbers that would never be able to be written as a fraction. And this one you might be most familiar with, and that's pi. That's 3.141592, so on and so forth. That pattern never repeats and it never ends. So there's no way we can read it, write it, reduce it. And there's no way we can put what repeats in the numerator because it never repeats. So this would never be able to be turned into a fraction. Pi is an irrational number. Here's another example, 0.1234567891011121314, so on and so forth. That pattern would go on forever without repeating. It would not repeat. It would not terminate. That number is an irrational number. Here's another one, 0.101100111000. That pattern would go on forever without repeating, and it would not terminate. Not a rational number. And then here's a number that's got a bunch of random digits that aren't repeating or terminating. That is an irrational number. And then lastly here, kind of the same thing, 1.313311333111. That pattern would go on forever without terminating. So that is an irrational number. So can I identify if a number is rational or irrational? Here are a bunch of different types of numbers. Let's go through and identify whether they're rational or not. 0. Is it rational or is it not rational? Well, 0 can be written as a fraction. Well, 0 is an integer and it's a whole number, so I know that is rational. I can write 0 as a fraction. 0 fourths or 0 fifths or 0 with anything in the denominator would be 0. That'd be equivalent. What about 1 4 fifths? 1 4 fifths. Can I write that as a fraction? Yes, 1 4 fifths is 9 fifths as a fraction. That is rational. It can be written as a fraction. Next one, 1.414213562, so on and so forth. It does not appear that this decimal repeats or terminates. That is irrational. 8.32 repeating. This is a repeating decimal, so I could write this as 8 32/99. Once I can write that in fraction form, I know that that's rational. Up here, the number 5. 5 is a whole number. I could write that as a fraction. I could write that as 5 over 1. I could also write it as 10 halves, or I could write it as 15 thirds. These are all equivalent to 5, so they can be represented as a fraction. That's rational. Negative 8 fourths. Well, that's already written as a fraction. It can be simplified to negative 2 or negative 2 over 1. Either way, it can be written as a fraction. That's rational. Pi, we just saw on the last slide. Pi is an unending, not repeating decimal value that is irrational. And negative 632. Well, negative 632 over 1 is a fraction that is rational. If it can be written as a fraction, it's rational. And then finally, how do I compare these types of numbers? So I've got rational numbers, I've got irrational numbers. Can I compare them to one another? Here, 2/3 and 0.67. How do we tell which one is bigger, or are they equal? Well, again, in our last video, we learned how to compare these types of numbers. I'm going to convert them to their decimal value. So if I take 2 divided by 3, that converts that to 0.666. That's 0.6 repeating. And if I compare that to 0.67, I see that 0.67 is larger, so 2/3 is less than 0.67. Over here, if I line up my decimal values here, I have 0.010. Those are the first digits here. And I can see right here that this one is larger. 1 is bigger than 0. So the one on the left is less than 0.011. Down here, 14 fifths is a improper fraction. If I convert that to a decimal by taking top divided by bottom, 14 divided by 5 is 2.8. And if I compare my place values here, 8 is bigger than 7. So 14 fifths is greater than 2.7545. And then here I've got a couple of fractions, negative 8 sevenths and negative 5 sixths. If I convert these to their decimal values, 8 divided by 7, I get negative 1.142857 repeating, and negative 5 sixths is negative 0.83 with the 3 repeating. So then I can see right here, negative 1 is less than 0. So that is going to be less than negative 5 sixths. So that's how we compare all these types of numbers. So again, rational numbers, any number that can be written as a fraction.